Welcome to this lecture, Laplace Transform, Part 7. In the last two lectures, we have seen differential equations, how to solve differential equations using Laplace Transform. We will continue that. We will continue to see more differential equations and how to solve them using Laplace Transform. And further, we are going to discuss on the nature of the solutions also. Well, so this is the equation we are going to solve today. Second order linear differential equation, d square y by dt square plus dy by dt plus y equal to 1. All the initial conditions are 0. So as usual, take Laplace transform on both sides. So the Laplace transform, if you take Laplace transform on both sides, taking Laplace transform, this we get this. So this is the first term, Laplace transform. We have been used to this. We have seen 2-3 times earlier. Laplace transform of this, s square ys minus sy naught minus y dash. This is y dash first first derivative. And this is the Laplace transform of this. And y means is y of t. So y is a function of t. So Laplace transform of y of t is y of s. Laplace transform of y means y of t, function of time. So the transform is y of s. And right hand side is 1. Transform of 1 is 1 by s. Now all the initial values are 0. So if you substitute, this is 0, this is 0, and this is 0. So you are left with these two ys terms only. So if you take ys common, ys into s square, ys into s, and here this ys plus 1. So these terms are all gone. This is gone. All initial values are gone because they are 0. So the remaining terms, this and this and this, are written taking ys common. So ys into s square plus s plus 1 equal to 1 by s. If you bring this term to this side, y of s equal to this 1 by this. Now before taking inverse, we have to split into partial fraction. Before that, we see if we can factorize this. This s square plus s plus 1 cannot be made into any more integer factor. Okay, you can factorize it, but you won't get an integer factor. Okay, there's no integer roots. So let us retain this as such, s square plus s plus 1. So since it's the second order, you have to use bs plus c by this. So let us evaluate these constants a, b and c. As usual, we will compare the terms. If we compare the independent terms, that is s power 0 term, left hand side independent term is a here, and that's all. There is no other independent term. So right hand side independent term is 1. So you get a equal to 1. Next, let us compare s square term. If you compare s square term, left hand side you have a square and you have bs square. So left hand side a square terms is a plus b. Right hand side there is no s square term, 0. So already you got a is 1. So this means b is minus 1. So next we need a, b, c we have to find out. So let us compare s term. If we compare s term, you have as plus bs. No, there is no bs. You have cs, as and cs. So s coefficient is a plus c. So again right hand side s term is 0, a plus c equal to 0, so a equal to 1. So this means c is also equal to minus 1. So you got a is 1, b is minus 1, and C is minus 1. B and C are minus 1, A is plus 1. So if you substitute this in this equation, A is 1, B is minus 1, C is minus 1. So let me substitute. If I substitute, I am going to get this. A is 1, B and C are minus 1. So I taken minus common. Minus S is here, minus S. Taken minus S, minus common, so plus S and plus 1. So this is why S after splitting into partial fraction. Now how do you find the inverse? This cannot be factorized, we said earlier, so we have to retain this and then find the factor. So what I am going to do is, what we can do is, we can express this term S square plus S plus 1 as a sum of two squares. Okay, so let us write this S square plus S plus 1 as sum of two squares. S square plus S plus 1. If you see the first two terms, S square plus S, we can consider it as sum of two squares. One is S plus half whole square. If you take S plus half whole square, expand it, first term will be S square, second term will be 2 into S into half, that is S. So the two terms, first two terms of S plus half whole square will be S square plus S. Now the third term independent, what should be this next? Plus what? So let me further expand. So this is S square. If we expand this, is S square plus 2S plus half square is 1 by 4. So plus, what will be this? We need 1. So we have 1 by 4. So this term must be 3 by 4. Right? So S square plus S plus 1 is same as S square plus 2S plus 1 by 4 plus 3 by 4. So that is nothing but sum of two squares. So it is S plus half whole square plus this is what? Root 3 by 2 whole square. So this S square plus S plus 1 can be written as sum of two squares, S plus half whole square plus root 3 by 2 whole square. So that is what I have done here. So IFS, so this has been written as S plus 1 and the denominator has been written as sum of two squares. This, the denominator S square plus S plus 1 is written as S plus half whole square plus root 3 by 2 whole square. The next step, S plus 1, the numerator is S plus 1. How do we do this? I am going to make, see if you consider this. This is S plus 2 whole square plus this. Now I will make the numerator also similar to this, S plus 2. Here whatever you have here S plus 2, I will make this numerator S plus 1 as S plus 2. And if I modify it S plus 1 as S plus 1 by 2, S plus half, right? So this S plus 1, this S plus 1 I have written as S plus half plus half. To be the same as this, to be the same term as this, idea is this numerator partially will be the same as this. Okay, now again I will split this now. So now I will split this into this term, whole thing into two terms. This is 1 by S written as such, and this term is written as this, that is this is written as first S plus half, this 2 divided by this, and minus sign, minus half divided by this half divided by this. I hope it is understood. All I have done is I split this S square plus S plus 1 into sum of two squares, this, and then the next step the numerator modified as same as this, s plus half, and I return this, that's all. Now, do you recall from my lecture part 1, Laplace transform part 1, table of transform? Do you recognize this? Do you remember this? What will be the inverse of this? This is something like k by s plus k. Sorry, a by s plus a whole square plus k square. So there is, if you recall, there is a translation of transform rule. Translation of transform. What is that rule? So if you recall our table of transform, you know this Laplace transform of this is e power minus at sin kt is this. Laplace inverse of k by s plus a whole square plus k square, that is this term. So this term is similar to this, right? And this term is similar to this. So Laplace inverse of this is e power minus at sin kt, and Laplace inverse of this is e power minus at cos kt. So let me write the inverse of this using this formula. So if you take inverse, first term is 1 by s. So 1 by s inverse is 1. Second term is s plus a, similar to this. A is half and k is root 3 by 2. So it is going to be e power minus at. A is half, so e power minus half t into cos kt. What is k here? K is root 3 by 2. So this is the inverse of second term. Then third term, the numerator is half, right? So numerator has to be made. Okay, the third term I'll write here. The third term, it is numerator is half, right? Half by something. Half by this. The third term, this. Now instead of half, I need this formula. K I need root 3 by 2. So I have to make root 3 by 2 here. I need actually root 3 by 2. But what is already there is half. So I have to divide by 1 by, I have to divide by root 3. So this half, all I have done is I return this half as 1 by root 3 into root 3 by 2. That's all. I return this half as 1 by root 3 into root 3 by 2. So if you consider that, so root 3 by 2 is k. This root 3 by 2 is k, same as this. So you have an extra constant 1 by root 3. So 1 by inverse of that, this term is 1 by root 3, 1 by root 3 e power minus at, e power minus at, minus at is, a is half, into sine what? Sine kt. K is root 3 by 2. This Laplace of sine e power minus at sine kt should have k on the numerator and k square in the denominator. But here you have k is root 3 by 2. The numerator it is not k, 1 by 2. That is why I had modified this as k. K is root 3 by 2 multiplied by 1 by root 3. So 1 by root 3 is extra, I mean the common, it's a constant I taken out here, and remaining will conform to this formula. Remaining will conform to this formula. So I written this. So this is the inverse. Hope understood. Hope it is clear. Next step, I just take an e power minus half t common. This e power minus half t I taken common. Take an e power minus half t common. So next, so if I take e power minus half t common, this is the term cos root 3 by 2 into t minus 1 by minus I taken common. So it is plus here plus 1 by root 3 sine of root 3 by 2 t. So this is your final solution. Of the given differential equation, which has got a cos term and a sine term multiplied by e power minus half t preceded by 1. So you have 3 terms in the ys. These are the corresponding inverse. So y of s inverse is 1. This term inverse is corresponds to this equation. So inverse of this is e power minus half t according to this formula, and inverse of this corresponds to this formula. This. We have made use of these two formulas. So I hope you have understood and it is clear. In the next lectures again we will take up more differential equations and solve them using Laplace transform. Well, I think there is a small error, very insignificant error. Let me correct it. Anyway, there is no final answer will not be different. Final answer is the same. What is that mistake? Let me go back here. Yeah, this term it's a small mistake here. This is not 2s. This 2 is not there. This must be simply s. That's all. Okay, that's a small mistake. Please correct it. I will also correct it here. I will also correct here. This is not 2. Okay, so there is no 2 here. It must be simply. So that's all. That's it. So this term must be, this is simply s square plus s plus 1 by 4. So plus 3 by 4 equal to 1. Rest all there is no change. This all right. Everything is right. Only this 2 has come here by mistake. So rest all same. There is no other change. Everything is fine. Final solution is this. This is the final solution, which is correct. Everything else is right. Only that extra factor 2 has come here, which I corrected now. That's all. Okay, so we'll see next lectures with some more differential equations. Bye till then.